So in the previous class, we were discussing the properties of steel. So we studied the geometric properties of steel. What is the die of steel, deform bar, and how to calculate the cross-sectional area, weight per unit foot. Then we were discussing the strength of the reinforcing bars. So normally the reinforcing bars are available in 4 grades, grade 40, 50, 60 and 75. And grade of a steel reinforcing bar means it is the minimum yield strength of that reinforcing bar. However, the most commonly used reinforcing bars, the most commonly used grades of reinforcing bar used in the construction industry, they are grade 40 and grade 60. So obviously grade 40 means the minimum yield strength will be 40, and grade 60 means the minimum yield strength will be 60. And these are, remember, these are the specified yield strengths of steel reinforcing bars. Okay, the actual strength may be different from these values, and the actual strength you can calculate from the test. You might have conducted the test, UTM test on the steel reinforcing bars in your engineering mechanics lab course. So from that you can calculate the actual yield strength and the actual ultimate strength. Now the ultimate strength for grade 40 is 70 KSI, and for grade 60 it is 90 KSI. Clear? It is very simple. अगर आप इसको याद करना चाहते हैं तो बस इसके साथ 38 करें या 60 के साथ 38 करें. So these will be ultimate, and these are also specified ultimate strengths, specified yield strength and specified ultimate strength. They are not the actual yield strength and actual ultimate. These will be used for the design of reinforced concrete structure members. Clear? These values will be used for the design. But if you see the actual stress strain curve for a steel bar, it is somewhat like this. Clear? So this point corresponds to the yield strength of the reinforcing bar, and this maximum stress, this corresponds to the ultimate strength of the reinforcing bar. So this is the actual stress strain curve. However, for design purpose, we convert this curve into elastoplastic curve. What we do, this is the yield point. We assume that there is a linear variation of stresses and strains up to yield point, and after the yield point there will be no increase, there will be no strain hardening in the steel. You know that this is the strain hardening region, and the ultimate strength will be greater than the yield strength. But we, for design purpose, we idealize this true stress strain curve into a bilinear or elastoplastic curve. Now, why we do this? There are two advantages of converting this stress strain curve into bilinear curve. And the one advantage is that this much strength, this is kept as a reserve strength. So this is basically a factor of safety on the material level, which is basically material overstrain. जिस तरह मोटरसाइकिल वगैरह में रिजर्व ऑयल होते हैं which are used in case of emergency. So this strength will be kept as a reserve strength. We are not using this much strength in our design, so which means that we will be using only yield strength in our design. Clear? The strain hardening portion of the stress strain curve is ignored in the design. Clear?
Yes, sir.
So this is one advantage, and the other advantage of converting this curve into bilinear curve is that it makes our calculations very simple. So for example, this is the stress strain curve. So what we are doing basically, you will see this in the coming lecture, that in reinforced concrete mechanics, what we are doing, we basically, first of all, from strain comparability equations, we calculate strains in concrete and reinforcement. And then from those strains, the corresponding stresses are calculated. Okay. So for example, this point, it corresponds to yield strain. This is the yield strain of a bar. For example, what will be the yield strain of grade 40 bar? Anyone? Yield strain of grade 40 bar. Quickly, Shabash. It is very simple. It is the this relation Fy divided by elastic modulus. Fy is 40 and elastic modulus, you know, it is 29,000. So what is the value, Shabash, quickly? I think it will be equal to 0.00138. So this is the yield strain of grade 40 steel. Clear? So this idealization means that up to yield strain, the stresses will be proportional to strains. Or the strain elastic. Okay. So up to yield point, you can apply this Hooke's law, that is stress will be proportional to strains. Clear? Similarly, if you calculate the yield strain of grade 60 steel, so it will be equal to 60 divided by 29,000. It will be equal to 0.0021. So you should remember these values because these will be used in the design of reinforced concrete members. Clear? In the previous lecture, we studied another important parameter of concrete, which was crushing strain of concrete, which was equal to 0.003. So you should remember these three values: crushing strain of concrete, yield strain of grade 40 steel, and grade 60 steel. These will be used in the reinforced concrete mechanics. Clear? Now, if the strains in reinforcing bars, they are less than the yield strain, how this idealization makes our calculation simple. So if the strain in reinforcing bar is less than the yield strain, then stress in reinforcing bar can be calculated very easily from the Hooke's law, and which is equal to strain multiplied by elastic modulus. Clear? And if strain in reinforcement is in this region, that is strain in reinforcement is greater than the yield strain, then directly Fs will be equal to Fy. That is, stress in reinforcement can be directly taken equal to Fy, because actually the stress in reinforcing bar will be greater than Fy. Corresponding to this strain, you can see the stress will be somewhere here. But how to calculate this stress? For this, you need an equation for this portion of the curve. So from that equation, then you can calculate the actual stress value at this strain. However, this idealization makes the calculation simple. If the yield strain is greater than the strain in reinforcing bar is greater than the yield strain, then directly you can take the stress in reinforcing bar equal to Fy. ये बात समझ गए आप लोग? हेलो
सर प्लीज दोबारा समझाएं सर।
ये तो बिल्कुल सिंपल है मेरे ख्याल में। आप देखें, ये जो एक्चुअल स्ट्रेस स्ट्रेन कर्व है, इसको हमने आइडियलाइज किया एज ए बाइलिनियर कर्व. यू कैन सी हियर दिस येलो कलर कर्व. उसमें अगर आप देखें तो बिलो दिस वैल्यू, if strain is below EY, then the stresses can be calculated because there is a linear relation. You can see here it is in the elastic limit. So the stress in reinforcing bar can be calculated directly from the Hooke's law. That is strain multiplied by the elastic modulus. ये समझ में आ रही बात? यहाँ तक समझ गए कि नहीं?
Yes sir.
अच्छा, if the strain in reinforcement or the reinforcing bars is greater than the yield strain, for example strain value is here, ये point आप देखें. Now what will be the stress corresponding to this strain? So the stress corresponding to strain will be somewhere here. ये है ना? This will be the stress corresponding to strain. इस तरह है कि नहीं?
Yes sir.
अच्छा, अब ये स्ट्रेस आप किस तरह कैलकुलेट करेंगे? कोई बता सकता है? Stress corresponding to this strain which is greater than the yield strain, ये स्ट्रेस किस तरह कैलकुलेट करेंगे? कोई कैलकुलेट कर सकता है स्ट्रेस?
सर जी फोर्स पर यूनिट एरिया से हम कैलकुलेट कर सकते हैं.
नहीं, फोर्स तो आपके पास है ही नहीं ना. फोर्स कहां से आ गई?
एक्सक्यूज मी सर
जी,
इसको सर स्ट्रेन को सर इलास्टिक मॉडुलस के साथ मल्टीप्लाई करके
वो तो अलाउड है अप टू इलास्टिक लिमिट. नाउ वी आर in the portion greater than the yield strain. We have crossed the elastic limit. यही तो मैं बता रहा हूँ ना
सर. मॉडुलस ऑफ टफनेस के साथ जो इसके अंडर मतलब जो एरिया है,
देखिए इलास्टिक मॉडुलस के साथ जब आप मल्टीप्लाई करेंगे स्ट्रेन को, तो यू विल गेट द स्ट्रेसेस. इट इज वैलिड अप टू द इलास्टिक लिमिट, अप टू यील्ड पॉइंट. So in the first portion it was okay. We calculated the strain, the stresses from the Hooke's law. That is strain multiplied by elastic modulus. But now we are in this region. We have crossed the elastic limit. There is E strain which is greater than the EY. And corresponding to this strain, how to calculate this stress? So for this you need an equation for the curve, for this portion of the curve. For this portion of the curve, you need an equation, and from that equation, then you can calculate the stress value at this point. अब बात समझ में आ रही है कि नहीं?
यस सर.
जाहिर है कर्व है ना, उसके लिए एक इक्वेशन डेवलप करना पड़ेगा, एंड फ्रॉम दैट इक्वेशन देन यू कैन कैलकुलेट द स्ट्रेस। अब समझ में आ रही बात?
Yes, sir.
Now, but if you idealize this curve as elastoplastic curve, then you don't need to develop any equation for that. For this, directly the stress in the reinforcement can be considered as this one. So what is this value? Yellow आप dot जरा देखें. If we ignore that part in the design, if we say that we don't take the strength greater than the yield strength in our design, okay, we ignore that strain hardening portion of the stress strain curve. So then the any strain, for any strain greater than the yield strain, what will be the stress?
सर yield stress होगा ना?
Yield strain होगा, बिल्कुल सिंपल है। तो अब आप देखिए आइडियलाइजेशन से कितना आपका जो कैलकुलेशन है सिंपल हो गई, कि बजाय इसके कि आप एक इक्वेशन डेवलप करें फिर उससे स्ट्रेस कैलकुलेट करें, डायरेक्टली if the strain is greater than EY, then Fs can be directly taken equal to Fy. अब समझ गई बात?
Yes, sir.
इसमें कोई कंफ्यूजन है तो पूछे।
सर जी ये लीनियर ग्राफ को हम क्या कहते हैं?
लीनियर ग्राफ को क्या कहते हैं? लीनियर ग्राफ कहते हैं?
नहीं सर जी, एक तो ये रियल ग्राफ हुआ ना स्टील का।
अच्छा, ये आइडियलाइज कर्व है, एक उसका रियल स्ट्रेस कर्व है, और ये जो येलो कलर है दिस इज आइडियलाइज्ड, इसको हम इलास्टोप्लास्टिक कर्व भी कहते हैं, बाइलिनियर कर्व भी कहते हैं।
ओके सर।
Now you can see here the actual stress strain curve, which is represented by the solid line, and the idealized curve, which is represented by the dashed lines. You can see here in this portion, that is when E, that is strain is less than the yield strain, the stress can be calculated from the Hooke's law, and if the strain is greater than the yield strain, then directly stress can be taken equal to Fy. Clear? So this idealization makes your calculation very simple. Clear? Building codes and the ACI code. A code is a set of technical specifications and standards that controls the important details of design and construction. So it is a set of specification. So I told in the previous class that specifications, they are basically the part of the code which contains the properties desired from a material. The properties desired from a material is covered in the specification part, and how to ensure that those properties are achieved. How to ensure that for a specific material those properties have been achieved. So for that you need to test that material, and for that the standards will basically provide you the procedure for the corresponding tests. Clear? So it is basically a set of specification and standard that control important detail of design as well as construction. The purpose of code is to produce sound structures. Sound structure means safe and economical structures, so that public will be protected from poor and inadequate design and construction. अच्छा, हम बार बार कह रहे हैं कि इंजीनियरिंग डिज़ाइन ऑन द वेरी फर्स्ट स्लाइड भी हमने ये डिस्कस किया था, इंजीनियरिंग डिज़ाइन शैल बी सेफ, and economical. Clear? So you have to satisfy these two requirements in the design of a structural component. Clear? General building codes, they cover all aspects of building design and construction, from architecture to structural, mechanical and electrical, HVAC, etc. So every aspect of a building is covered in these general building codes, such as UBC 97, for example, the latest code, Uniform Building Code, IBC, which is International Building Code, the Euro Code. They are basically the general building codes. It covers all aspects of a building. Clear? Then there are some specific codes, like for example, seismic codes. So they will cover only the seismic provisions, provisions related to earthquakes of buildings, such as SEOC, which is Structural Engineers Association of California, NEHRF, which is National Earthquake Hazard Reduction Program of USA, and BCP SP, Building Code of Pakistan, which is basically derived from UBC 97, seismic provision, which is developed in 2007. Material specific codes are like ACI, which we will be using this course, especially ACI 318. So American Concrete Institute, this is a code. AISC is another code, which is American Institute of Steel Construction, which is used for the design of steel buildings. And AASHTO, which is used for the design of bridges, roads, etc. And there are some other codes such as ASC, American Society of Civil Engineers. It covers the minimum design load requirement, minimum loads for building and other structure, especially live loads. So ASC 710, it contains the minimum live loads for different occupancy of buildings. Clear? This is the main document, ACI MCP, which is Manual of Concrete Practice, which contains 150 ACI committee reports, revised after every 3 years. So one of the committee report is ACI 318, which basically covers the structural concrete, the requirements for structural concrete, building code requirement for structural concrete. And structural concrete may be plain concrete, it may be reinforced concrete, and it may be pre-stressed concrete. Clear? And in this course, we will basically be following ACI 318 for the structural design of the structural components. Clear? ACI 318-19. So the latest version is ACI 318-19, which will be used in the design of reinforced concrete members. Clear? Then there's another committee report, which is ACI 315, which basically deals with the detailing of structural members. ACI 349, it deals with the nuclear safety related concrete structures, and many others. Like for example, ACI 352, it is basically covering the requirements for the environmental structures. Similarly, ACI 350, it covers the requirements for the design of beam column connections. Okay? So total 150 ACI committee reports, which are covering different types of concrete used in different environments. Clear? The American Concrete Institute building code requirement for structural concrete, which is ACI 318, referred to as the ACI code, provides minimum requirements for structural concrete design or construction. Clear? So it provides minimum reinforcement. So remember that code will always provide you some minimum requirements. You will not provide less than those requirements. You can exceed those requirements because you will never compromise on the safety. You can compromise on the economy, but as a structural designer, you can never compromise on the safety because finally the whole responsibility will be on your shoulders. Okay? Like for example, one of the example is that the requirement of ACI for special moment testing frame is that the column size must not be less than 12 inch by 12 inch. So if you are designing a special moment testing frame, then the column size must not be less than this. So as per this requirement, you can never provide a column of size 11 inches or 10 inches or 9 inches. Okay. However, you can provide a column size greater than this, like for example 15 inch by 15 inches, 18 inch by 18 inches, and so on. Clear? But you cannot provide a column size less than this one. Okay. The term structural concrete is used to refer to all plain or reinforced concrete used for structural purposes. However, pre-stressed concrete is included under the definition of reinforced concrete. But if there are separate provisions for pre-stressed concrete, then it will be mentioned in the code. G.
सर ये जो प्लेन कंक्रीट है ये विदाउट रिइंफोर्समेंट है
क्या?
ये प्लेन कंक्रीट है, ये कौन सी कंक्रीट है जिसमें रिइंफोर्समेंट इस्तेमाल नहीं हो या कौन सा?
नहीं, रिइंफोर्स्ड कंक्रीट कॉलम की जो मिनिमम रिक्वायरमेंट है फॉर स्पेशल मोमेंट टेस्टिंग फ्रेम एज पर ACI 318, वो ये है कि आप 12 इंच बाई 12 इंच से कम साइज नहीं दे सकते. जी समझ गए?
सर क्वेश्चन ये नहीं था, मैं प्लेन कंक्रीट और रिइंफोर्स कंक्रीट में डिफरेंस की बात कर रहा हूँ.
जी जी, आप यहाँ पर देखें ना, इज यूज्ड टू रेफर टू ऑल प्लेन or reinforced concrete. Plain concrete is that concrete in which there is no reinforcement. And reinforced concrete, you know that concrete which is reinforced with the steel bars.
ओके सर, मैं यही पूछ रहा था. थैंक यू.
Okay. So of course, you will design the different structural members for the applied loads. So loads can be defined, they are defined in ACI 318-19. The load is defined as forces or other actions that result from the weight of all building materials. So self weight of a structural member is also a load. Clear? It is also a type of dead load. Similarly, load of the occupants and their position. So positions means the chairs, tables, beds, etc. Environmental effects, okay, snow loads, wind load, etc. Differential moments, for example, settlement of support. Restraint dimensional changes, for example, creep and shrinkage, stresses. Now, permanent loads are those loads in which variations over time are rare or of small magnitude. Now, basically, if you see, there are two types of loads. Broadly, there are two types of load. One is called permanent loads, which will act on the structure for a very long time, or it will be there for all the time. And variable loads, which will act for a specific period of time on the structure. So permanent loads, it may be self-weight of the structure member, or it may be superimposed load. Like for example, permanent attachments, tiles on the floors, etc., or the walls on the floors. They are called superimposed load or self-weight. These two, they are called dead loads. And variable loads may be live load, earthquake loads, environmental loads, environmental may be snow load, or it may be wind load. Okay. So these are the variable loads, because they will act on the structure, not all the time. It will not be there all the time on the structure, but they will be there for some period of time. Clear? Now the live load. Live load, basically these are the load of the occupants mainly, and their positions. They are categorized as live loads. Clear? Now these three, they are basically categorized as gravity loads. Clear? Because they act in the gravity direction. And earthquake and wind load, they are basically lateral loads. They act in the lateral direction mainly. Okay. So this was the conclusion of all this discussion. Dead load, the weight of members, supported structure permanently, and permanent attachments, accessories that are likely to be present on a structure in service. Loads meeting specific criteria found in the General Building Code without load factors. Clear? Load factor आगे हम पढ़ेंगे. Live load that is not permanently applied to a structure but is likely to occur during the service life of a structure. It is likely to occur during the service life of a structure. Clear? There is probability that this load will be applied on the structure during the service life. So such type of load, they are called live loads, but excluding environmental loads. So I told you that variable loads, live load, environmental loads, they are basically variable loads. Clear? SEI specifies live load magnitude for various occupancy or uses. From this table, you can see the live load values for different occupancies. Clear? You can
Sir
see. जी
ये बैक स्लाइड में ये बी नंबर लाइन की समझ नहीं आ रही. बैक स्लाइड सर जी, ये बी नंबर.
Load meeting specific criteria found in General Building Code.
Without load factors.
Without load factor, अभी आगे अपन पढ़ेंगे ना. Load factor मैं उस पर आ रहा हूँ. सही?
Okay.
अच्छा, यहाँ तक समझ गए? Basically,
Yes.
आपके पास gravity loadings, there are two types of gravity loading. One is the dead load, and as I told you, dead load may be the self weight of the structure, or it may be any other superimposed load like permanent attachment. Okay, they are basically categorized as superimposed dead loads. So there are two types of dead loads: self weight and any other permanently attached loads to the floor. Clear? So these loads, you can calculate these loads. These are deterministic. You can calculate these loads from its respective unit weights. For example, you have a 6-inch slab, so you can calculate the load of this slab per square foot on the floor is 6 divided by 12 multiplied by its unit weight. For example, it is 150 pound per foot cube. So this will be equal to, on a floor can be expressed pound per square foot. Load acting on a beam can be expressed in terms of pound per foot per linear foot, because it is a line load. And load acting on a column is basically a point load. It can be simply represented in terms of pounds or kips. Clear? So the dead loads, they are deterministic. They can be calculated from the unit weights. Thickness of the member multiplied by its unit weight, it will give you the load per square foot. Or for example, there is superimposed load. For example, there is tile on a floor. For example, there is 3-inch tile on a floor. So you can calculate this load very easily. The thickness, which is 3 by 12, you convert this into foot and multiply by its unit weight. So for example, the unit weight of tile is 120. So from this you can calculate the superimposed dead load. So the superimposed dead load are the self weight of the structural member, for example slab. They can be calculated very easily from its thickness multiplied by its unit weight. Clear? They are deterministic. They can be calculated with high degree of accuracy from these equations. Clear? However, the live load, on the other hand, this is not deterministic load. You cannot calculate the live load with high degree of accuracy. For any structure, the live load, the variation in the live load is very high. So you can determine the live load probabilistically. Probabilistic load, it is not deterministic. Okay, so ACI will provide you the values directly. क्योंकि आप देखें, आप लाइव लोड को, फॉर एग्जांपल एक क्लासरूम है, इवन क्लासरूम के लिए भी आप एग्जैक्टली लाइव लोड कैलकुलेट नहीं कर सकते. If there are 40 students in a classroom, there will be 25 students, sometimes there will be 45, sometimes there will be registered, so up to 50 is not determined. Clear? So this can be determined probabilistically. So based on the probabilistic study on many buildings for different occupancies, for the worst conditions, some values have been proposed by the codes, and from those tables you can directly pick the live load for a specific occupancy. Clear?
Yes, sir.
So this is the table, and in this table you can see that these are different occupancies. Clear? And this is the loading for the given occupancy. For example, for office use, the live load is given here. It is 50 pound per square foot. For computer use, it is 100. Clear? Similarly, you can see for different occupancies, these loads are given. For residential building, clear? You can see here one single family dwelling. For that, the live load will be 40 pound per square foot. Okay. Similarly, for classroom, the live load is also 40 pound per square foot. Clear? For a classroom, the live load will be 40 pound per square foot. And these are very conservative values. As I told you, they are basically, these values are for the worst conditions. So there is these values will be quite conservative. ये आप इस पर एक एक्सरसाइज भी कर सकते हैं. For example, as I told you that live load for classroom is 40 pound per square foot. इसको अगर हम for example कैलकुलेट करें, live load for classroom given in ACI as well as in the AAC, it is 40 pound per square foot. Now, for example, if we take a classroom of our department, and normally how many students are in a class?
40.
कितने students होते हैं? 40. चले हम 50 students लेते हैं conservatively. For example, there are 50 students in a class. और एवरेज वेट कितना होगा एक स्टूडेंट का? ये बता सकते हैं? पाउंड में बताएं. एवरेज वेट कितना होता है आप लोगों का?
सर 150 पाउंड.
150 pound is average weight of a student. Clear? अच्छा, अब इससे जरा टोटल वेट of 50 student calculate करें. It will be 50 multiplied by 150. It will be equal to how much? इस तरह 7,500 pound is the total weight of 50 students. यहाँ तक clear है? It just
Yes,
to
sir.
make you feel that how conservative are these values given by the code. Just आपको एक फीलिंग देने के लिए ये एक्सरसाइज कर रहे हैं, सही, ताकि आपको पता चले कि कोड्स के वैल्यू कितने कंजर्वेटिव है. अच्छा, एक क्लासरूम की जो हमारे क्लासरूम्स हैं डिपार्टमेंट के, उसकी जो एरिया है इन साइज, ये आप लोगों ने कभी कैलकुलेट किया है? ये कितना है? रफली जरा बताएं.
सर 12,000 पे 18 होगी सर.
ये 12,000 बेटा नहीं, 12,000 बेटा नहीं, 20 by 30. सही
सर 25.
हाँ, मेरे ख्याल में 25 है. 25 25 by 30 है मेरे ख्याल में. चलिए हम 20 by 30 लेते हैं. 20 by 30 या मोर कंजर्वेटिवली 20 by 25 लेते हैं. सही. नाउ डिवाइड दिस total weight by this much area. So 7,500 divided by 25 multiplied by 20. तो ये ज़रा कैलकुलेट करें. What is the weight per
15
square
psi.
foot?
15
15
psi.
psi नहीं यार,
PSF सर.
PSF. अब आप देखें, हमने कंजर्वेटिवली 50 स्टूडेंट्स लिए और हर एक स्टूडेंट का जो वेट है वो हमने 150 लिया. Still you can see the weight is 15 pound per square foot only. You can see that how much conservative are these values suggested by the code. Clear? Just आपको एक फीलिंग देने के लिए ये जो वैल्यूज है ये काफी कंजर्वेटिव होते हैं. Why? Because they are not deterministic. You cannot determine the live loads with high degree of accuracy. You can determine these values only probabilistically. Clear? And since there is chance of high variation in the live load, so therefore the load factor for live load is 1.6. So we will also multiply live load with this factor 1.6 for the design. And this 1.6, this is not an arbitrary value. This has also been calculated based on probabilistic studies. And what does it mean? It means that there is a chance of 60% increase in the live load during the service life of a structure. Clear? And for dead load, the load factor is 1.2. So 1.2 dead load and 1.6 live load. जो आपने अभी पूछा पिछले स्लाइड में लोड फैक्टर के बारे में, तो these are those load factors. Because there is less variation expected in the dead load, so that is why the load factor for dead load is less than that for the live load. Clear? And what does it mean? 1.2 means that there is a chance of 20% increase in the dead load during the service life of a structure. Clear? And as I told you, these factors are also determined based on probabilistic studies. Clear? So for design, you will you will calculate dead load and live load. Dead load can be calculated very easily from the unit weights, and live load can be picked from the table, and then you will multiply live load and dead load with its respective load factors. Clear? Any question?
सर जी, ये डेड लोड का किस तरह चांस होगा कि ये 20% इंक्रीज हो जाए? लाइव लोड तो ठीक है, वो तादाद जब ज्यादा हो जाए, लेकिन डेड लोड किस तरह 20% इंक्रीज होने का चांस है?
वो तो बिल्कुल सिंपल है. आपके पास फ्लोर पर टाइल्स हैं या चिप्स है फॉर एग्जांपल, और आप अगर उस पर आयल लगाना चाहते हैं, तो बजाय इसके कि आप इसको रिप्लेस करें, क्योंकि उसको रिप्लेस करने के लिए भी आपको आप पर एडिशनल लेबर कास्ट आएगी, तो आप उस चिप्स के ऊपर ही टाइल्स लगा देते हैं. अब जब चिप्स के ऊपर आपने टाइल लगा दिए, तो अब ये इंक्रीज इन द डे हुई, चिप्स का लोड भी है और आगे से आपके पास ये जो है टाइल का लोड भी आ गया. ये चांस तो है ना?
यस सर, ओके सर.
बात समझ आई?
यस सर, समझ आ गई. तो
इसकी भी चांसेस है, प्रोबेबिलिटी है कि इसमें भी इंक्रीज है। मगर आप देखें क्योंकि डेड लोड almost 60 to 70% dead load will come from its self weight, और सेल्फ वेट तो चेंज नहीं होगा। यानी फॉर एग्जांपल आपके पास 6 इंच स्लेब है तो चेंज नहीं होगा नॉर्मली। ये सुपर इम्पोज डेड लोड चेंज हो सकता है। फॉर एग्जांपल चिप्स के ऊपर आपने टाइल लगा दी, बट दैट विल बी वेरी स्मॉल एज कंपेयर टू द सेल्फ वेट एंड द other superimposed dead load. So that is why the load factor for dead load is 1.2. It is less than that for the live load. Clear?
Yes, sir.
Other loads include earthquake load, wind load, and snow loads. Now, what are service loads? अब ये बिल्कुल सिंपल है। आपने डेड लोड कैलकुलेट किया फ्रॉम द यूनिट वेट्स, जो कि मैंने पिछले स्लाइड पर आपको समझा दिया, और लाइव लोड आपने पिक किया फ्रॉम द टेबल। अब इसको हम कहते हैं सर्विस लोड्स, और जब आप इसको मल्टीप्लाई करें लोड फैक्टर्स में तो फिर उसको हम कहते हैं फैक्टर लोड्स। क्लियर? In a dead load,
Yes,
our
sir.
live loads की value without factors. The dead load and live load values without factors, they are called loads. And if you multiply dead load and live load with its respective load factors, then it becomes the factor loads. Clear?
Yes, sir.
Now, there are two approaches for the design of a structural member. मगर इससे पहले I think we should discuss the concept of demand and capacity. वो ज़रा डिस्कस करते हैं क्योंकि उसके बगैर आप इसको नहीं समझेंगे। सही? Okay, so we have discussed different types of loads. Now, all these loads, when they act on a member, they will be called as demand on the given member. Clear? So, demand is basically all the applied loads, its self weight or externally applied loads acting on a member, they are called demand and on that given member. Clear? Now, these loads we discussed in the previous class, that these loads will produce whatever the load, the type of load is, whether it is dead load, live load, earthquake load, or any other type of load. It will basically produce four types of actions: axial force, moment, bending moment, shear force, and torsion. So loads may be given in the form of these four actions. And these will produce load effects, which are also called stresses. So stresses, as a result of these actions, you have also studied the stresses, the relation for stresses for these different actions. From your mechanics courses, you know that the axial stress will be equal to P divided by A, the stresses produced as a result of bending moment. It can be calculated from this equation. Shear stresses as a result of shear force can be calculated from this equation, and torsional stresses can be calculated from this equation. Okay. So finally, what does it mean? It means that the demand may be in the form of loads like axial force, bending moment, shear force, and torsion, or it may be given in the form of stresses or load effects. Load effects and stresses, they are same, because stresses are basically the effect of these applied loads. Clear? Now, what is capacity? Capacity is basically the overall load carrying capability of a structural member. This is called capacity. The overall load carrying capability of a structural member is known as capacity of that member. Clear? Now, how to determine this capacity? This you can determine by applying demand on a member, and the maximum demand which the member can take without failure is known as the capacity of that member. Clear?
Yes, sir.
So the capacity is basically the product of strength and geometry. What does it mean? It means that by increasing the strength of a material, you can increase the capacity of that member. And also, by increasing the size of member, you can also increase the capacity of that member. Okay? Students, strength or capacity में अक्सर confused होते हैं. So increasing the size of member, it will not increase the strength of that member. Strength will remain the same because it is material property. However, the capacity will be of that member will be increased. Clear? यानी अगर आपके पास दो सैंपल्स हैं, what is this sample? It is made up of concrete of strength Fc prime, and now there is another sample having the same strength. Now, can you tell me which one of these sample will take more load?
Sample B.
B part.
Sample B. B will take more load because the capacity of B is greater than the capacity of A. And why? Because the size, the geometry of sample B is greater than the geometry of sample A. Clear? The strength is same, but the geometry is different. Clear? Since the size is increased, so that is why the capacity will be increased. अच्छा, आप इससे strength increase नहीं होगा, ये याद रखें. Strength will remain the same. Clear? Strength of sample B will remain the same, but since the geometry is increased, so that is why the load carrying capability or the capacity will be increased. अच्छा, अगर हम इसी size का एक sample ले लें, this is a sample which is of the same size, but now this sample is made up of steel, Fy. For example, this is sample C. अब मुझे बताएं which one will take more load, sample A or sample C?
C.
C. Why? Because now the strength of sample C,
Is more than
you increase the strength of sample C. The geometry remains the same. But since the strength of sample C is greater than the strength of sample A, so the overall load carrying capability of sample C or the capacity will be increased. अब बात समझ में आ रही है? ये स्ट्रेंथ और कैपेसिटी की समझ आ गई आपको?
yes.
Yes,
So
sir.
by increasing the size of a member, by increasing the geometry or by increasing the size of a member, you can improve the capacity of that member, but the strength will remain the same. By increasing the size of the member, you cannot increase the strength of that member. Clear? अगर आपको याद हो सिलेंडर टेस्ट, कंक्रीट सिलेंडर टेस्ट, तो उसकी स्ट्रेंथ आप किस तरह कैलकुलेट करते थे? आपको याद है?
Yes, sir. Maximum load divided by cross section area.
हाँ, आप देखें मैक्सिमम लोड कैसे थे? डिवाइड बाय क्रॉस सेक्शनल एरिया. अगर इसी सैंपल के लिए हम ले लें, फॉर एग्जांपल सैंपल को हम इंक्रीज करें, तो अब मुझे बताएं कि जो मैक्सिमम लोड है फॉर दिस सैंपल, इट विल बी ग्रेटर देन दिस सैंपल और नॉट?
No, sir. Same.
नहीं, मैक्सिमम लोड की मैं बात कर रहा हूँ. Maximum load for sample B, maximum load which can be taken by sample B will be greater than the maximum load taken by sample A or not?
Yes, sir. Greater than A.
Greater होगा ना?
Yes, sir.
But स्ट्रेंथ को किस तरह आप कैलकुलेट करेंगे? आप इस मैक्सिमम लोड को डिवाइड करेंगे एरिया पर. तो यहाँ पर आप देखिए स्ट्रेंथ इज द रेशो, तो द टोटल स्ट्रेंथ रिमेन द सेम, क्योंकि अगर आप देखिए एरिया भी ज्यादा है ना.
Yes, sir.
जी सर.
अगर इसको हम ए कहें और इसको हम पी भी कहें, इसको हम A1 कहें, इसको हम A2 कहें, तो PB is greater than PA, but on the other hand A2 is also greater than A1, so the ratio will remain the same, which means that the strength will remain the same. Clear? क्योंकि strength तो ratio है load divided by area का. So by increasing the area you have increased the capacity, so it will take more load. But now if you calculate the strength, so you have to divide that load by its cross-sectional area, and when you divide it by its respective cross-sectional area, the strength will remain the same. Clear? अब समझ में आ रही है बात?
Yes, sir.
Yes, sir.
So the conclusion is that you can increase the capacity by increasing the strength of the material or by increasing the geometry of the material. And if there is same material, so then by increasing the geometry you can increase the capacity, but the strength will remain the same. Clear? Now again, if I write capacity is the product of strength and geometry. Now this geometry, technically this is called as geometric modulus. Okay, in case of axial force,
Yes, sir.
the geometric modulus in case of axial force, it is the cross-sectional area. In case of bending moment, the geometric modulus is moment of inertia divided by C. आप यहाँ पर देखें जरा, if you want to calculate the axial capacity of a structural member, एक्सियल कैपेसिटी ऑफ स्ट्रक्चर में किस तरह कैलकुलेट करेंगे? शाबाश, कोई बता सकता है? स्ट्रेंथ ऑफ द स्ट्रक्चरल मेंबर मल्टीप्लाइड बाय द एरिया। सिंपल है ना? तो एक्सियल कैपेसिटी ऑफ ए reinforced concrete member will be equal to FC prime compressive strength multiplied by area of the structural member. समझ में आ रही बात?
Yes, sir.
So in this case, the geometric modulus is area. If you want to calculate the moment capacity, so it will be equal to Fr multiplied by I divided by C, where Fr is the tensile strength of concrete and I divided by C, it is called section modulus, elastic section modulus. So in this case, the geometric modulus is I divided by C. Clear?
Clear.
Acha, in case of shear strength, shear capacity, for the shear stresses, the equation was BQ divided by IB. So from this you can calculate the shear capacity. It will be equal to shear strength multiplied by IB divided by Q. So in this case, the geometric modulus is this IB divided by Q. This is the shear strength and this is the geometric modulus. Clear? In case of torsion capacity, if you calculate the torsion capacity, so for torsion stresses, it is equal to T rho divided by J. So this will be equal to torsional strength multiplied by J divided by rho. So in case of torsion capacity, this is the torsional strength and this is the torsional geometric modulus. अब बात समझ में आ रही है? So capacity is basically the product of strength and the corresponding geometric modulus, जिसको हम geometry कहते हैं, सही? In case of axial capacity, it is the product of strength multiplied by the geometric modulus, which in this case is cross-sectional area. In case of bending moment capacity, it is the product of flexure strength multiplied by geometric modulus, which is denoted by I by C. It is also equal to section modulus. S can be represented by S. In case of shear capacity, the shear capacity will be equal to the shear strength multiplied by the shear geometric modulus, which is represented by IB by Q. And in case of torsional capacity, it is the product of torsional strength multiplied by geometric modulus. Clear?
Yes.
In case of reinforced concrete member, this Fr, this we have discussed in the previous class, it is equal to 7.5 FC prime. And this shear strength, in case of reinforced concrete member, it is 2 FC prime. And this geometric modulus, this can be simplified into this B into effective depth. Effective depth हम आगे पढ़ेंगे. And torsional strength in case of reinforced concrete member is equal to 4 under root FC prime. Clear? So you can calculate the capacity, the axial capacity, bending moment capacity, shear capacity, and torsion capacity of structure member. Now we discussed in the previous on the previous slide, that the demand will also be in the form of these different actions. So if the demand is given in the form of loads, for example, axial load, okay, so you will compare it with the axial capacity. बात समझ आ रही है? The demand is given in the form of bending moment, so you will compare it with the bending moment capacity. Similarly, shear demand, so you will compare it with the shear capacity. If the demand is given in the form of torsion, so you will compare it with the torsion capacity. Similarly, if the demand is given in the form of stresses, for example, axial stresses, so then you will compare it with the strength of the material. Clear? If the demand is given in the form of flexural stresses, then you have to compare it with the flexural strength. If the demand is given in the form of shear stresses, then you have to compare it with the shear strength of the concrete. And if the demand is given in the form of torsional stresses, then you have to compare it with the torsional strength of the member. बात समझ में आ रही है? So demand may be in the form of loads, and it may be in the form of load effects or stresses. If the demand is in the form of loads, then you have to compare these with the capacities of the structural member. And if the demand is given in the form of stresses, then you have to compare it with the corresponding strength of the structural member. एक एग्जांपल इस पर करते हैं तो आपको ज़्यादा क्लियर हो जाएगा. For example, there is a reinforced concrete member which has a dia of 8 inches, for example, and the load acting on this member, this is 200 kips. Now, of course, for the safe design, the capacity shall be greater than the demand. ये तो आप लोगों को पता है ना? Or the strength shall be greater than the stresses. यहाँ तक आप लोग समझ गए कि नहीं? आवाज आ रही है?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. For engineering design, for the safe design, the capacity shall always be greater than the demand. Clear? Because if the capacity is less than the demand, so the member will fail. अच्छा, अब ये एक हम इस पर एक एग्जांपल करते हैं. The strength of material is given, it is 3000 psi. Clear? And the demand on the member is given in the form of load. अच्छा, अब मैंने जिस तरह कहा था कि demand is given now in this case in the form of load. अब इसको आप किससे के साथ कंपेयर करेंगे? If the demand is given in the form of load, then you have to compare the demand with its capacity. Now, what will be the capacity of this member? It will be equal to strength multiplied by geometric modulus. So it is equal to area. Now, capacity will be equal to Fc prime, which is 3000 psi. So it will be equal to 3 ksi. And multiplied by area. Area, you can calculate the area for this member. Quickly calculate करें शाबाश. 5 by 4 d square से calculate करें. 5 by 4 8 square. जल्दी करें शाबाश. What will be the area of this?
50.24.
G.
50.24.
32. Yeah.
50 sir, 50.24.
50.24 ये इंच स्क्वायर। अब इसको यहाँ पर मल्टीप्लाई करें 50.26 इंच स्क्वायर, तो व्हाट विल बी द कैपेसिटी ऑफ दिस मेंबर? क्विकली यार, जल्दी करें। यार ऑलमोस्ट इट विल बी
150.79.
150.7.
15720.
अच्छा, 150 किप्स इज द कैपेसिटी ऑफ द स्ट्रक्चर मेंबर। अब आप जरा कमेंट करें, द मेंबर विल फेल और नॉट, or the under the given demand the member can
Yes, sir. Fail.
stand the given demand or
Sir, fail.
it will fail, because you can see this capacity is greater than the demand, which is equal to sorry, it is less than the given demand, which is 200 kips. So the member will fail for the given loading. Clear? अच्छा, अब हम क्या कर सकते हैं to improve this capacity? How to improve the capacity? क्या
सर एरिया को ज्यादा करेंगे।
एरिया को ज्यादा करें? दूसरा ऑप्शन क्या है?
सर मटेरियल को भी चेंज कर सकते हैं सर, स्ट्रेंथ मटेरियल
मटेरियल की स्ट्रेंथ सर बढ़ा दे।
स्ट्रेंथ को हम ज्यादा करें, या
यस सर,
it is the combination of strength and
स्ट्रेंथ ऑफ मटेरियल।
area. तो या तो आप स्ट्रेंथ को इंप्रूव करें या आप एरिया को इंक्रीज करें। क्लियर?
यस सर।
अच्छा, अब for example the material is fixed, the material properties are fixed, you cannot increase the material strength, so the only option is then that you have to basically increase the area of the member. अच्छा, अब ये एरिया हम कितना इंक्रीज करें? यानी 8 इंच की बजाय 8 इंच डाई की बजाय अब हम 12 इंच डाई भी दे सकते हैं, 20 इंच डाई भी दे सकते हैं, 50 इंच डाई भी दे सकते हैं। जितना हम इसको इंक्रीज करेंगे so the capacity will be increased. अब बात समझ में आ रही है कि नहीं?
यस सर।
सही?
सर 9.5 इंच अगर
तो
हम ले तो सर तकरीबन सेफ रीजन पे आते सर।
हम अगर हम सेम तो नहीं रखते ना
सर 9.5
We'll
इंच अगर हम डाया ले ले तो
provide
सर
some factor of safety in our design.
Excuse me, sir.
The capacity, remember, for the design the capacity should be जी तो क्या?
Sir, if you multiply this with the
The
load
capacity
factor,
will be equal to the demand. यही बात कर रहे हैं आप? वो आगे हम बताएंगे आपको। देखिए, आपके पास एक तरीका है कि आप ये इस कैपेसिटी को आप कैपेसिटी इफ सी प्राइम मल्टीप्लाइड बाई ए, इसको डिमांड के साथ आप कंपेयर करें। From this you can calculate the required area. Now this area will be equal to 200 divided by how much?
3000। यस सर।
ये जरा मुझे बशाबाश क्विकली। 3000 की सही नहीं है ना, ये किप्स में है।
यस सर।
Always the unit shall be consistent. Clear?
66.6.
200 divided by 3.
66.66.
66.6 inch square. Clear? Now from this you can also calculate the dia, because pi by 4 d square is equal to 66.67, and from this you can calculate d square is equal to 4 divided by pi multiplied by 66.67, and if you calculate d,
Yes, sir.
it will be
9.21. 9.21.
okay, so the dia will be equal to 9.21 inches. Clear? So it means that you need this much dia of structural member so that the capacity is equal to demand. अच्छा, अब ये जो हमने डाया कैलकुलेट किया, for this the capacity will just be equal to the demand. इस तरह है ना, हमने यहाँ पर equal किया ना.
Yes, sir.
For this dia capacity will be equal to demand, but we say that the capacity shall always be greater than the demand. For safe design, we need that the capacity shall be greater than the demand. बात समझ में आ रही कि नहीं?
Yes, sir.
Clear? अब ये कितना ज्यादा होना चाहिए? This will be basically given in the code. Code will tell you that how much your capacity shall be greater than the demand. Clear? क्योंकि मैंने आपका कैपेसिटी तो आप बहुत ज्यादा भी बढ़ा सकते हैं ना, यानी आप डाया जितना इंक्रीज करेंगे, डाया आप फॉर एग्जांपल 10 इंच लेंगे तो कैपेसिटी विल जस्ट बी ग्रेटर देन द डिमांड. आप अगर 20 इंच लेंगे तो कैपेसिटी और भी इंप्रूव हो जाएगी. 30 इंच लेंगे तो मजीद आपकी कैपेसिटी इंप्रूव हो जाएगी. तो ये कितना हम इंक्रीज करेंगे? क्लियर? बिकॉज आप जितना ये डाया इंक्रीज करेंगे तो कैपेसिटी तो इंक्रीज होगी, मगर साथ साथ you will compromise on the economy. More material will be used in the construction of the structural member. Personally, जितना ज्यादा डाया आप यूज करेंगे तो इतना ज्यादा मटेरियल भी यूज होगा ना. हेलो?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
And in the previous class we discussed that the engineering design must be safe as well as economical. तो आप सेफ्टी तो प्रोवाइड करेंगे, मगर साथ साथ जो डिज़ाइन मस्ट बी इकोनॉमिकल. तो इतना ज़्यादा भी आप इसको नहीं बढ़ा सकते. तो कितना बढ़ाएंगे? तो बेसिकली the code will basically tell you that how much you should increase the capacity of the structural member. Clear? Acha, how to increase this? So for this we will study in the coming slides, but before this I will also calculate if for example the demand is given in the form of stresses. So for the same problem, if for example the stress is, you calculate the stresses, so the stress will be equal to 200 divided by area. Area is equal to 50.26 inch square. So how much will be the value of stresses? जल्दी कैलकुलेट करें ना यार. 200 डिवाइड 50 ऑलमोस्ट 4 KSI. आवाज आ रही है आप लोगों को?
Yes, sir.
Hello? Now the demand is given in the form of stresses. So I told you if the demand is given in the form of stresses, so directly you will compare it with the strength of the material. So now the stress is equal to 4 KSI, which is greater than the strength of the material, which is 3 KSI. So again, in this case, you can see that the member will fail for the given demand. बात समझ में आ रही है अब? यानी अगर आपको डिमांड इन द फॉर्म ऑफ स्ट्रेस गिवन हो तो बस आप डायरेक्टली उसको स्ट्रेंथ के साथ कंपेयर करें. If the demand is given in the form of load, then you have to compare it with the capacity of the structural member. ये बात समझ में आ रही है?
Yes, sir.
Okay. Now we say that the capacity shall be greater than the demand. Clear? How much the capacity shall be greater than the demand? So this will be greater than the demand by a factor of safety. Clear? In other words, the ratio of capacity to demand is known as factor of safety. Up clear? Eh? So in an engineering design, you need some rational factor of safety in your design. You will always incorporate some margin of safety in your design, which means that your capacity shall always be greater than demand by a factor of safety. Normally we take this factor of safety equal to 2. Clear? Any question up to this point? Clear?
Yes, sir.
Yes, sir.
And not only in engineering, in your routine, you incorporate some margin of safety अगर मैं आपको एक सिंपल सा मिसाल दूं, for example, if you have the capacity of sitting in the class for the 5 hours, but you will never tell me that we can sit in the class for the 5 hours. After 3 hours, you will stop me and you will say that we cannot absorb anymore. Clear? So you have this capacity, but you are keeping some margin of safety. Clear? बात समझ में आ रही है कि नहीं?
Yes, sir.
So capacity shall be greater than the demand by a factor of safety. Now, how to incorporate this factor of safety in your design? So there are 3 ways basically of incorporating this factor of safety in your design. For example, the factor of safety is 2. Clear? So one way to incorporate the factor of safety in your design is by increasing the demand intentionally. Clear? So for example, the capacity is same, and if we multiply demand with 2, so what is the factor of safety in this case? कोई बता सकता है? अगर मैं डिमांड को 2 से मल्टीप्लाई करूं, इसको इक्वेशन को इसके साथ कंपेयर करें.
सर 2 है सर.
तो फैक्टर ऑफ
सर ये
सेफ्टी
डिमांड तो कम हो गई ना, कैपेसिटी इंक्रीज हो गई.
जी, डिमांड को आपने 2 के साथ मल्टीप्लाई किया, तो it means that you have factor of safety of 2 in your design. So one way of incorporating this 2 factor of safety in your design is that you multiply demand, you increase the demand. So increasing, one way of incorporating the factor of safety is increasing the demand on the member. Clear? जिस तरह आप लोगों ने जी
एक्सक्यूज मी सर सर ये डिक्रीजिंग इन डिमांड या इंक्रीजिंग इन डिमांड है
ये इंक्रीजिंग डिमांड है आपने
सर यहाँ पे तो कैपेसिटी फिर नहीं सर ये तो कैपेसिटी इंक्रीज हो गई ना डिमांड तो डिक्रीज हो गई
नहीं डिमांड इंक्रीज हुई आप देखिए डिमांड को हमने 2 के साथ मल्टीप्लाई किया अच्छा सेकंड हम जो प्रोसीजर है वो भी बताते हैं तो आपको समझ में आ जाएगा The second way of incorporating this factor of safety is decreasing the capacity. If we decrease the capacity by 2, then from this equation again और वही equation में दोबारा लिख देता हूँ capacity is equal to factor of safety multiplied by the demand. Clear? Now capacity is equal to 2 multiplied by D. अब जरा मुझे बताएं what will be the factor of safety in this case?
2.
So again the factor of safety is 2. But now you have incorporated the factor of safety, the same factor of safety, by another way, by decreasing the capacity. अब बात समझ में आ रही है? So you can incorporate the factor of safety by increasing the demand or by decreasing the capacity. बात अब समझ में आ रही कि नहीं? You can incorporate the factor of safety either by increasing the demand or by decreasing the capacity. यहाँ तक समझ गए कि नहीं?
Yes, sir.
Here is another way. Again मैं वही equation लिख देता हूँ capacity is equal to factor of safety multiplied by the demand. If I decrease the capacity, as well as increase the demand by some factor. अब इसको जरा आप सिंप्लीफाई करें तो capacity will be equal to 1.4 multiplied by 1.45 into D. अब ये जरा मुझे बताइए 1.4 multiplied by 1.45 is equal to how much? जल्दी बताइए यार
2.03 D.
2.23 so almost 2D. अब कोई बता सकता है what is the factor of safety in this case?
True.
2. Now, but the same factor of safety you incorporated by another way. You decrease the capacity as well as increase demand. So this is the third way of achieving the desired factor of safety in our design. Now this last approach, the method of incorporating the factor of safety, this is basically the strength design approach. ये सारा किस्सा हमने इसके लिए किया सही. In the strength design approach, the demands are increased, okay, and the capacities are reduced. The demands are increased by respect to your load factors. यानी आपके पास अगर डेड लोड हो तो आप इसको 1.2 में मल्टीप्लाई करें, लाइव लोड हो तो 1.6 में मल्टीप्लाई करें, और कैपेसिटी किस तरह रिड्यूस करेंगे? वी विल रिड्यूस द कैपेसिटी बाय स्ट्रेंथ रिडक्शन फैक्टर. वो आगे हम पढ़ेंगे, मगर यहाँ तक समझ गए? In case of strength design approach, the demands are increased, are amplified, and the capacities are reduced. और ये जो हमने second method of achieving the factor of safety, ये जो हमने पढ़ा, decreasing the capacity, this is basically working stress approach. So what we are doing in working stress approach, we directly reduce the capacity intentionally to achieve the desired factor of safety. और कैपेसिटी भी नहीं, बल्कि हम स्ट्रेंथ को 2 पर डिवाइड करते हैं। यानी अगर हमारे पास Fc प्राइम इज द स्ट्रेंथ ऑफ द मटेरियल, तो अब बस आप इसको 2 पर डिवाइड करें। में 3000 psi जिस तरह हमने उस एग्जांपल में लिया था, इंस्टेड ऑफ 3000 psi you will take 1500 psi in your design. So that will be basically your factor of safety in the design. बात समझ में आ रही है? And the demand is kept the same. Clear? So in working stress approach, the factor of safety is incorporated just by dividing the strength by 2. Simple. But now in case of working stress approach, the demand is kept the same and the capacity is achieved by just dividing strength by 2. Arbitrarily,
सर
जी
क्लास बस करते हैं सर, नेट इशू भी है सर, लाइट भी नहीं है सर, चार्ज भी खत्म है सर,
ये
और
बस
लेट हो रहे हैं
लास्ट,
सर, बज रहे हैं सर।
हाँ ये बिल्कुल लास्ट स्लाइड है। इसके बाद बस वो 2 स्लाइड है, वो ये ऑलरेडी हमने इस स्लाइड पर पढ़ दिए।
ओके सर, थैंक
ये
यू।
समझ गए कि नहीं?
यस सर, समझ गया।
So the strength is just reduced by 2 arbitrarily. There is no rationality. डिमांड को भी आप सेम रखते हैं और कैपेसिटी को भी आप बस जस्ट रिड्यूस करते हैं by reducing the strength. Clear? But on the other hand, in case of strength design approach, you are increasing the demand as well as decreasing the capacity, and both are based on scientific rationale. You don't increase the demand arbitrarily. यानी अगर आपको याद हो, मैंने आपको बताया था that dead load is increased by a load factor of 1.2, live load is increased by 1.6, and these factors, they are determined based on probabilistic studies. It is not arbitrarily taken. Clear? It is based on scientific rationale. बात समझ में आ रही है? The demand is increased based on scientific rationale because there is a chance of 20% increase in the dead load during the service life of the structure. Similarly, in case of live load, you are increasing the demand by 1.6 because there is a 60% chance. There is a chance of 60% increase in the live load during the service life of the structure. Clear? Similarly, in case of strength design approach, the capacities are reduced. Okay, now in case of strength design approach, this increase in the demand, this factor, this is denoted by gamma. This is basically load factor, and this factor, which is 1 divided by 1.4, this is denoted by phi or phi. So the capacity is reduced by phi. P multiplied by C is equal to gamma multiplied by D. Okay, so from this you can also calculate the factor of safety. C divided by D will be equal to gamma divided by phi, where gamma will always be greater than 1. आप देखें 1.2, 1.6, and phi will always be less than 1 because this is strength reduction factor. अच्छा, अब ये strength reduction factor भी arbitrary नहीं है. It is also based on scientific rationale. It is also taking care of different actions. यानी अगर आप for example axial load के लिए, compressive load के लिए, the strength reduction factor will be equal to 0.65. In case of bending moment, flexural load, the strength reduction factor will be equal to 0.9. Clear? Now, since the flexure failure mode is ductile, it is a well-defined failure mode, there will be cracking, then yielding leak. So in mode, so that is why you can see the strength reduction factor for flexure load is 0.9. While on the other hand, the member subjected to compression load, in that case the failure will be quite brittle. As soon as the compressive load exceeds the compression capacity, there will be abrupt crushing of the concrete. And since the failure mode is brittle, so that is why the strength reduction factor is 0.65. Similarly, in case of shear, the strength reduction factor is 0.75. So in case of the shear design, shear failure is also brittle as compared to flexure failure. So that is why the strength reduction factor for shear is also less than that for the flexure failure mode. Clear? तो अब आप देखिए strengths capacities are reduced but based on scientific rationale. haphazardly हम नहीं करते. It is taking care of these different actions. But on the other hand, in case of working stress approach, you don't take of these different actions. You just divide FC prime by 2 to achieve the desired factor of safety. Clear? So
Yes,
that is
sir.
why in this course we will use the strength design approach for the design of reinforced concrete structural member. Clear? We will not use the working stress approach for the design of structural members. We will use strength design approach for the design of structural members. अब बात समझ में आ रही है? तो ये जो हमारे पास वर्किंग स्ट्रेस अप्रोच और स्ट्रेंथ डिजाइन अप्रोच, इसके लिए हमने ये सारी कहानी की. आप यहाँ पर देखिए कैपेसिटी इज रिड्यूस्ड बाय हाफ, डिमांड इज केप्ट द सेम. अब तो आपको समझ मेरे ख्याल में आएगी ये बात. Clear? While in the strength design method, the loads are amplified and the capacities are reduced, but both will be based on scientific rationale. Arbitrary हम नहीं करते, सही? So the strength design method is more rational as compared to the working stress approach. That is why we will use the strength design approach in the design of structural member. And this we have discussed this how to calculate the factor of safety in case of strength design method. Of course, you need mechanics, reinforced concrete mechanics for the design of reinforced concrete members. So mechanics can be qualitative and quantitative. इस सिंपल अल्फाज में अगर मैं समझाऊं तो क्वालिटेटिव का मतलब ये कि फॉर एग्जांपल आपके पास एक सिंपली सपोर्टेड बीम है and is subjected to this loading. अब आप मुझे बताएं where will be compressive stresses, in the top fiber or in the bottom fiber?
Top fiber.
In the top fiber there will be compressive stresses and in the bottom fiber
Tensile.
stresses.
this is known as qualitative mechanics. And qualitatively आप लोगों को पता है कि compressive stresses there will be compressive stresses in the top and tensile stresses in the bottom. Now how to calculate these stresses? For this you need quantitative mechanics, जो कि आप लोगों ने already पढ़ी है. How to calculate these stresses from this equation my divided by I. For this equation, this is basically based on quantitative mechanics. अब बात समझ आ रही है?
Yes, sir.
Mechanics of reinforced concrete will be slightly different from the mechanics which you have studied in your previous courses. However, if you know the basics of equilibrium and compatibility equation, your concepts are clear on those topics. So then the mechanics of reinforced concrete is also very simple. Why it is different from those? Because reinforced concrete is a composite material. It is made up of concrete and steel. and at a very smaller loading, it gets into non-linear range. Will be cracks, and after the appearance of cracks, the behavior will be non-linear. Okay? The formulation of design equation for axial flexure, shear, and torsion stresses is based on the mechanics of reinforced concrete and will be taught in these respective topics. In this course, we will only cover these three, the design for axial flexure and shear. The mechanics of reinforced concrete for flexure will be discussed in detail in the next week lecture. So in the coming lecture, inshallah, we will discuss the mechanics of the reinforced concrete member subjected to flexure loading. Clear? This was, I think, the last slide. Now, if you have any question, you can ask the question. अच्छा, इस पर ये जो हमने वर्क एंड स्ट्रेस फॉर एग्जांपल अप्रोच पढ़ा, तो इस पर आप ये अब प्रॉब्लम भी सॉल्व कर सकते हैं। ये जो हमने प्रॉब्लम सॉल्व की है, इस पर अगर आप सॉल्व करना चाहते हैं तो इट इज़ वेरी सिंपल. You can take this FC prime divided by 2, so capacity will be equal to 1.5 KSI multiplied by area. आप इसको कंपेयर करें डिमांड के साथ 200, and from this you can calculate the area 200 divided by 1.5, which will basically provide you an area which will be safe for the given demand. Clear? इससे आप एरिया कैलकुलेट कर सकते हैं. Any question? आप लोगों को आवाज आ रही है?
Yes, sir.
Any question in this lecture? Shabash. Don't have any question?
No, sir.